All right. And also, before I address your question, let me put up here stats from the quiz. The average was a 76.8. Standard deviation was small. That's pretty small. What does that mean? Anybody? If the standard deviation is small, what does it mean about the data? Yeah, the data is not very spread out. Normally, when you're doing a quiz or a test and you see a very small standard deviation, that means people made the same mistakes. You see what I mean? And as a teacher, you can clue in on what did it seem as if people weren't quite getting. The pass rate was 62.5%. But of course, you guys can make corrections. I think, like number 4. Oh, let me do your question, then we'll go back to the quiz. So you said number 5 on the practice test? Yes, good. That's the point in number 5. Good. So hopefully you guys clued in on number 5. So if I gave you that kind of problem on the test, I would say find the answer or tell me why there is one, right? Because the way it's worded on there, I agree, it's a little evil, but that was a practice test, so I could be a little evil if I want to. Okay, so on the quiz. Well, all right, there are 2 different versions of the quiz. The problem where you had to identify the shapes, some were trapezoids, some were squares, some were rhombuses, and some were parallelograms. I had a lot of people identifying parallelograms as rhombi, right? What's the difference between a general parallelogram and a rhombus? What's the difference between a general parallelogram and a rhombus? Rhombus requires all sides to be equal, yes. So you could be a parallelogram, but not a rhombus. Just like you could be a rectangle, but not a square, for the exact same reason. Yeah, like that. You guys with me? You guys doing okay? I worry about you. I think part of the reason you might be feeling less than optimal, but oh well. Yes?
Sorry, would a square be a rhombus?
Yes!
Okay.
So, this is really, alright. I understand not everybody would be as excited about this idea. But a square is to a rectangle as a rhombus is to a parallelogram. And a rectangle is a specific kind of parallelogram, a square is a specific kind of rhombus, yes? So, and of course, a rhombus is a parallelogram just with one extra requirement. You guys with me? So there were some homework problems that talked about the requirements to be certain shapes, and that was like the problem, identify 4 things that are the same and 2 things that are different between rectangles and rhombuses. I was really excited somebody pointed out that, this was really cool, somebody pointed out that they're both one off from another shape, right? I can't remember who said it, but that was really cool. Somebody talked about the diagonals, which is really cool. Somebody talked about, anyway, there's a lot of things. Some of the obvious things were, what's similar? They're quadrilaterals. Now, if somebody wrote they're quadrilaterals, and then later they wrote they have 4 sides, is that 2 different pieces of information? No, that's the definition of quadrilateral. So you're not going to get credit for saying they have 4 sides if you already said they're quadrilaterals, because you already said they have 4 sides. Is everybody with me? Just in case it happened to a few people. Well, both are correct, but you didn't tell me something new. Okay. I like it. Maybe. Okay. So let me know if there's any more questions from the quiz. Yes. Or from the practice test.
Can you go to number 2 on the practice test?
Yeah. Yeah, number 2 is a decent little problem. Oh, let me wake this dude up. remember to get them to come in here and figure these lights out. Is that okay? Can you guys all see okay? Okay. There's nothing to see yet, I know. Yeah, okay. So number 2 looks incredibly busy, yes? On a test, I would probably give kind of a scaled down version of this, because on a test you might get flustered trying to collect everything that's happening. But on a practice test, I wanted to give us something with a lot going on. When you get a problem like this, you just immediately focus on any truth, right? Can anyone just tell me anything that must be true about any angle or set of angles, right? For example, what must be true about D and C? They add up to 180. So you start collecting a list of things that are true, yes? And then you try to see how they interact with each other. Does that make sense? That's one. Well, every approach has to involve that to some degree. What's true about, so then you start looking for those kind of things, yes? What's true about F and 132? Yeah, and then don't you know what F is? Do you see what I'm saying? Once you know what F is, it's going to help you figure out some other things, yes? What must B plus A be? For example, what do these 3 angles have to do? So 101 plus B plus A must be 180, correct? So can't you figure out what must be true about B plus A? Is everybody cool with what I'm doing right now? Now, again, let me remind you, on a test I wouldn't give you something with quite this many things going on. On a practice test, it's a really cool way to have a lot of relationships you have to work with, just so you can get used to how they all interact. On a test, I wouldn't give you something with A through F, because that's a lot to kind of like deal with in the middle of the test. Are you guys all with me? Okay. But you see how you can just keep going. What else do you know? Are there, now, I did think of it. L and M are parallel, so what other types of relationships could you look for? What's true about, let's see, D and B plus A? What's true about this angle and this whole angle? Why? Yeah, it's less important you know the name, but does anyone know the name? Those are 2, I think I heard somebody say it. 4 syllables. First syllable sounds like, huh? Corresponding. Yes. Because they are in corresponding locations. Yes? I don't really care that you know the name, as long as you know the relationship. Yes? Now, every single relationship we've pointed out, can you see it? If I understand when you see a problem, if you saw a problem like this on the test, you would feel very overwhelmed. That's where you just say, okay, calm down, let me just find a relationship, write it down. Find another relationship, write it down. Yes? Now I want to point something out. We just figured out that D equals A plus B, yes? Can you solve for A plus B here? Don't you then know what D is? Don't we also know what F is from earlier? I didn't write it down, but what's true about F? F plus 132 has to be 180. Do you see how it's a problem I like to call dominoes? Not the horrific, but the little tiles. Once you figure out one thing, it kind of knocks something else over, then knocks something else over. Yes? You guys see that? And the more, even if you can't finish, if I gave you this problem and you couldn't finish it, the more stuff you identify, the more points you're going to get. Because I'm looking for, can you see the relationships? Even if you don't get the answers, all the answers, if you show me you understand most of the relationships, you're gonna get a decent bulk of points. And this is why work is the most important thing. And this is why a math teacher that makes use of Scantron is not a math teacher. I don't know what they are, but they're not a math teacher. Okay. Let me stop. Is that okay to get started with that one? Who asked me about that one? Is that okay? Okay. And again, I've gotten it all worked out on the answer key, but I kind of want to leave a little bit for you guys to try. If you want to just try it out right now, go for it. But let me know if you have anything else you want to focus on. Are you guys, let me ask you this, anybody going to the Math Science Center for any help yet? You don't have to, yes? Are you getting help?
Yeah.
Yes, okay. Did they ask you for money? No? Okay. Free tutoring, right there, it's crazy. And I'm pretty sure, if I remember correctly, they have somebody on staff all the time that could do 126. Yeah. I like this. I think most of you guys are working that problem. I like it. So the F is, so what is F? 48 degrees. And what is A plus B? If you solve for A plus B? 79 degrees. So what's D? 79 degrees. So now I know D and F. I have to know E because they all live in a yellow submarine. No, they all live in a D, E, and F. They all live in a triangle. So they have to add up to be 180. So since I know D and F, I have to know E. Yes? Do you see the minute you identify something, it kind of like dominoes, it kind of like knocks something else over. Now you know two things, and they knock something else, and now you know more things, and now that knocks other stuff over. But this kind of problem can be a little overwhelming. I understand. But I will give you something like this just with a little less going on. You still have to know, of course, you have to know the names, but you have to know corresponding is the same, alternate interior. You're gonna have to know that. Yes? Okay. Is that better? Okay. Some of you guys have never had me before, and you're all like, good Lord, this guy can't write for shit. But the way this works today is if nobody's asking questions, it's entirely your floor. You can focus on whatever you want to focus on. I have literally brought nothing except the stuff I graded and the answer key. I didn't bring anything for a lecture. It's totally dependent on what you want to focus on. Yes?
Can we just bring any?
Anything except that one. No, I'm joking. All right, let's see. 3. Yeah, okay. So, Venn diagram. You guys should know that from 125. It's the box with the circles, yes? And I'm only gonna have how many circles? 2. So the whole question is, do they overlap, do they not overlap? Is one of them entirely in the other one? And if you've done the homework, you've seen ones where, like if it was a square, that would be entirely in the rectangle circle, yes? Every square is a rectangle, yes? What is the defining quality of a parallelogram? 2 sets of parallel lines, yes? What's the defining quality of a kite? The adjacent sides have to be congruent, yes? Okay. So, let me think, what was the thing on the quiz? I think I did almost exactly this on the quiz. Yeah, I did, didn't I? I have a thing about kites and parallelograms, apparently. It was exactly the same problem with the quiz, basically. So listen. Kite. The standard kite you're gonna draw looks like this, yes? I call that a square with a really big chin. You guys see if you draw a square as a diamond and you pull down on it, that makes a kite, yes? So if I push back up on it, it's still a kite. If I are you guys cool with this? If If I put my hand on top of that kite and my hand on the bottom, and I did this, it's still a kite, still a kite, still a kite. When it becomes a square, is it no longer a kite? Of course it's still a kite, because if it can become a square, maybe these sides are such that when I push it up, it becomes a rhombus, yes? Okay, to be a kite, you just need these two sides to be congruent, and the other two sides to be congruent, correct? You with me? Is that true for a general parallelogram? The two adjacent sides have to be congruent. Do these two have to be congruent?
No.
Because I just drew an example where that's obviously not true. Is there a parallelogram such that those two are congruent? What would you call it? A rhombus. So let me see. When you're making a Venn diagram, what's the most important thing about the circles? Do they overlap? And how much do they overlap? Yes? Didn't we just find a shape that lives in both definitions, kites and parallelogram? Therefore, when I draw the Venn diagram, the two circles must overlap. Now, are there any parallelograms that are not kites? Hell yeah, most of them, right? So I'm not going to have one circle entirely inside the other circle. Do you see what I'm saying? If I ask you to make a Venn diagram for any damn thing, one of your first concerns is how many circles, and then do they overlap at all? Entirely or not at all? Or in the middle, yes? So this one, how is it going to look? My two circles are going to, so here's kites. And here's parallelograms, they're going to do what? Overlap, but they're not going to live inside each other, yeah? Come on, parallelograms, live inside each other. Yes?
So wait, for those types of questions, are we only writing like the K and the P, or are we actually putting like the kite and the parallelogram
On the quiz, I said, I gave you the Venn diagram, and it said draw images. Here, I'm just saying draw a Venn diagram. That is a Venn diagram. KP is kites. The important thing I'm looking for in this problem is, did you put the circles the right way? If for part A, you had them not overlapping, that's wrong. If one was inside the other, that's wrong, yes? So, you can draw pictures for yourself, but to answer this question, I don't need the pictures. I didn't ask for pictures. Does that make sense? Now, we drew pictures and they helped us think about it, so feel free to draw pictures all damn day long. What about part B? Now, real quick, there's some misunderstanding about what scalene triangles are. Can somebody tell me what a scalene triangle is? All the sides are different. And what's the defining quality of an isosceles triangle? So what's the Venn diagram going to look like for your I circle and your S circle? They're not going to be touching at all, yeah? Once you're one of them, you cannot be the other one, yes? If you are an isosceles triangle, can you be scalene? No, because the defining quality of isosceles is two of the sides are the same. The defining quality of scalene is none of them are the same size.
By not touching, you mean like this?
Like not overlapping, yes. So this one, isosceles, scalene.
Got it.
Scalene. Sorry. Damn it, now it's gonna be in my head. Is that okay? So the one on the quiz, I specifically said put pictures in. This one you don't have to. I just want the Venn diagram. Yeah. Yes?
Can you question 5, please?
Oh yeah, somebody pointed something else, something about this earlier. How many degrees do I have already? 190. So what do you guys think? Can't do it. So I already said if I gave you a question like this on the test, I would word it like, find the missing angle if possible or something, you know what I mean? Yeah. This one made it sound like, you know, there is one. What would it have to be? -10 degrees. which, you know, is neat. It's gonna like scroll into it someday.
So I wrote not a real triangle. Is that a fine answer?
Beautiful. That is a fine answer. Oh, yeah. Okay, can you guys, here, you guys have some paper nearby before we go look at this one specifically? What's a simple curve? Can you guys draw a simple curve on your paper? A simple curve. Alright. So I'm going to draw my quad. Okay, that's a simple curve. Why is that a simple curve? Because it doesn't intersect itself. Yes? It doesn't create a loop. You guys with me? When I lived in Virginia, there was a street that intersected itself, which was always neat. I went, wow. If I make it a simple closed curve, which I think is what I called S up there. What's a simple closed curve? All I gotta do is take my curve and bring it back to itself. Yes. That is a simple closed curve. Can somebody tell me if that simple closed curve, and again, why is it simple? It's closed, obviously. Why is it simple? Because it never makes a loop. It never intersects itself. Does that make sense? Can somebody tell me if that's convex or concave? Convex, concave. Does it cave in on itself? Is one way to think about it. Like a circle does not cave in on itself, but if I smooshed it, then it would cave in on itself. Does it have anywhere it does this? Yes, it has a place where it dips in, yes? Or can you find anywhere 2 points that when you try to connect them, you have to leave? That's why to me it's kind of like closure. You have to leave. Yes, you do have to leave. So therefore, it's concave. Is that right? It never comes back on itself. What was the other thing I said up here? Convex, simple, closed curve, and n-gon. Yeah. How about this? Is this a simple curve? Yes. So all a polygon is it's a collection of simple curves that are closed, composed of line segments. So simple curves that are line segments that close. So that one I just drew. Is it an n-gon? Are the sides all line segments? So it is is it closed? Yes, so it is an n-gon. In fact, you could be specific what kind of n-gon it's 1, 2, 3, 4, 5, 6, 7. Did I count right? I don't know. Just count the sides. You can tell me if it's a 7-gon or an 8-gon. You guys kind of with me? I love you guys. And by the way, are you guys all cool? Like 5-sided figure. Give me 2 names for it. Pentagon? Or a 5-gon? Yes? And why do we do that shit? Because do you remember when I showed you the names and it was like supercalifragilisticexpialidocious? So I'd much rather say 77-gon than trying to come up with a name for all 77-sided figures. Yes? Okay. So what's a triangle? 3-gon. I like it. You guys all with me? All right. So let's look at the specific problem. Holy shit. What do you guys, no, I think C is the weirdest one. Is C an n-gon? No. And it cannot, there's like 3 distinct regions that are connected at vertices, yes? That is like 3 separate n-gons somebody's glued together. You guys with me? Okay. So an n-gon must be one region encircled by line segments. Now, okay. Let's look at A. Let's look at each one. Is A an n-gon? Totally. Why? All the sides are line segments. I love it. And they are closed. So how many things is this? Is it simple? Okay. Is it convex? Part A, is it convex? What does convex mean? And then what's the simplest convex picture I can make? A circle. Just remember that convex is circle. This does not have a dimple in it. Does this have a dent?
Yeah.
Okay, does that make more sense? A concave shape has a dent. So is A convex? No. Is it simple, closed? Yes, because it doesn't have a loop on itself. So this is simple. And what else? One more thing. N-gon. Is B an n-gon? Are all of its sides line segments? Nope. Is it a simple closed curve? What would be not a simple closed curve? If I had a circle that kind of went loop, right? If this is a closed curve that is not simple because of this. If it ever goes and intersects itself, if it ever has a loop inside or outside, if it intersects itself, it's not simple. Okay. So this one, it's not convex because it goes concave, yes? But it is simple, right? It's a simple closed curve. And it's not an n-gon because it's got sides that are circular shaped. It's not a line segment. C we already talked about. None of those things. What about D? Yeah, convex. Because it's almost like a circle that somebody just kind of like flattened the sides out, so it doesn't cave in on itself. So it is convex simple curve. It's also a simple curve, and if you didn't put S, you're fine because C has simple in it. Yes. Is it an n-gon?
Yes.
Yes, because all of its sides are line segments. Yeah. By the way, remember the stuff we went over last time? There were like three formulae. There were central angles, vertex angles, and interior. Central angles, vertex angles, which are also called interior angles, and exterior angles. Oh my god. I'm going to give you the formulas for those. Yes. Just because I'm looking at number 8. And number 9, of course. So remember the formulas for the angles had n in them because it depends on how many sides. And I really hope some of the math we talked about last time just makes sense. If there's 360 degrees total to go around and I have so many sides, I just divide 360 by how many sides. That's how much each slice gets, yes? And this is all for regular, the formulas are for regular polygons. Is number 8 a regular polygon? Can somebody remind me what a regular polygon is? All sides and interior angles are congruent, yes. So an equilateral triangle is an example of a regular threegon. Square is a regular fourgon. Your standard pentagon is a regular polygon, regular fivegon. Maybe. so expectantly. Like I said, you guys are controlling today completely. You guys tell me what you wanna talk about. Yes,
Can I get a practice?
maybe. Yes. I did say maybe. So this is no, too bad. Too bad for you. Come back in 1 year. So number 8, can somebody tell me one exterior angle? Do it again. CD is not an angle. CDE. CDE. So CDE would be created if I took this off. Let me just see if, let me make sure you guys really understand this. If I go like this, all right, I really want this to make sense. If I look at this extended side, this is the exterior angle for that. If I look at this extended side, remember, how do I create exterior angles? I just take any side and I kind of continue it. And then it's the angle that's closest to the next side, right? So if I continue this one, this would be an exterior angle. If I continue this one, this would be an exterior angle. Do you see how CDE is not an exterior angle? It's not an angle between an extension and the next side. That's an exterior angle. If I extend a side, the angle between that extension and the next side, that's an exterior angle. So up there, I've got an exterior angle. What's one exterior angle identified there? What's this angle here? Yeah, I would accept EDG or EDH. Do you see that? They're both the same angle. Do you see that? Okay, I like it. So there are actually several answers possible. And now you just kind of keep going around and you can collect, how many did it say? 3 exterior angles. So there's several answers you could give. Just don't give me, does everybody see how this is not officially an exterior angle? If I continue this is an exterior angle, yes? If I continue this is an exterior angle. It's got to be between continuous side and the next side.
So it can't be that middle.
When you say that middle one, what do you mean? Oh, it can't be, yeah, it can't be this guy. Because that's the angle between 2 extensions.
Yeah.
Okay, I like it. Oh, before you leave, here, you want the answer?
Oh, yeah. Thank you.
Yes.
So there's no exterior angles possible for where A is?
Yeah, A, well, let's see. If I, okay, Jeff, can't write on the board with your pen. If I extend this side, that's an exterior angle, yes? How do I identify that angle right there?
LBA?
LBA, ABL, right? A, when you say where A is, I wasn't sure what you meant, but A, the angle like A makes is completely not in contention. It's not. It's like not even by the shape I'm talking about. Does that make sense?
Mm-hmm.
So if I ask you this question, just literally pick any side, extend it. The angle between what you just did and the next side, that's an exterior angle. Okay, I like it. You would, John. And of course, what about the, and again, vertex angle is also called interior angle. Can somebody give me one vertex angle? Can somebody give me a vertex? Identify a vertex. D is a vertex, cool. So what is a vertex angle involving D? GDB, I love it. That would be vertex or an interior angle. Yes. I like it. I like it a lot. You would, Jeff? Weirdo. Yes. They're essentially the angles made by the vertices. Yeah, that's why I like vertex angle more than interior angle. If you find a vertex and then you just see what angle it makes inside, that's a vertex angle. Kind of unfortunate we don't, well, that would be a whole different class if we just focused. There's so much we could do with tessellations. It's silly. It is silly. But we're not doing a tessellation class, unfortunately. But I like number 10, I just wanted to give you like a next level thought process about them. This idea is kind of cool. It's like, what other shape can you make if you connect certain parts of what's there? It's kind of nifty. I don't know if anybody tried those out yet. It's
Love that one.
yeah. So in this one, do you see how here I picked a intersection point of all the parts? So that point, come on, you can do it, is where all my triangles meet. Yes, that point right there. So then I did all the midpoints between that point when I go out. I did all the midpoints and connected. So here, pick a point that is where sides of the shapes I'm using meet, yes? Like this one. Find all the midpoints for the lines coming into that. So find the midpoint of this, the midpoint of that, the midpoint of this, the midpoint of that. You with me?
Oh, okay, yeah.
And then connect the points you just made. Can you guys see what shape it's gonna make? A square. So squares, when you make a square tessellation, it's a little boring. It's like, look, I made myself. Good job. Now, triangles, do you see how, all right, do you agree that this is a tessellation made up of triangles? Yes. But do you see how it's also a tessellation made up of, what is this? The same shape we just got here is the shape that's, if I put all these together. Hexagon, yes. So do you see how they made that shape again? Now, down below, what is this one? That's also a hexagon. And if you try to make its midpoints, you get something kind of nifty. You get a very nifty relationship between these two. So pick a point where they come together, midpoint on those line segments, connect the midpoints, and what shape do you make? Triangle. So a bunch of triangles made a hexagon, a bunch of hexagons made a triangle. That's kind of nice. And a bunch of squares made a square. Square.
So we just have to draw out the.
Yeah, so pick, and again, never ever focus on the specifics of a problem on a practice test. Because I am not going to give you this problem on the test. Because I already gave you the problem. But pick a point, find the midpoint of all the line segments coming to that point. That's a really horrible job I just did. And then connect those points and you make a little triangle. So there's a lot of nifty mathematics inside of tessellations, behind creating tessellations. I showed you some of the Escher stuff if you were here last time. Here, I'm gonna go ahead and give you guys the answer key As I do this, if you haven't tried to practice this out, don't do this. Yep. I would have done that. Yep. Don't even look at this if you didn't try to practice this, because you're gonna build false confidence. It's easier to agree with me than it is to do the work, yes? So I don't want you to fall in that trap. So don't even look at this if you didn't try the practice test. Does that make sense? Okay. Did I finish that one? Or did I get tired? I might have gotten tired. Let's finish this one. I don't think I finished it. Let's see, I got F and I got D, which means E, F and D make 127, I believe, if you add those together. So E plus F plus D must be 180. So then E must be 180 minus 127. So E you get 53. Yeah. Let's see, what else can I say? Do you see about B, C, and 61? B plus C plus 61 must be 180. And since I know D, oh, I'm sorry guys, I love you guys so much. And somebody just tell me. I don't like projectors, but oh well, that's where I live now. So, over here I did E plus F plus D is 180. If I do 180 minus F and D, I get what E is, in the little triangle there, yes? Okay. B plus C plus 60, I'm sorry, not C. B plus E. So see this triangle here? B plus E plus 61 must be 180. Yes? Don't I know what E is? So therefore B must be 180 minus 114, which will be 66 degrees, I believe?
Yeah.
Yes, thank you. So what do we have left? We know we need to figure out A, B, and C. C is easy, because I know this. And just to remind you guys, again, I'm gonna say this one more time. If I give you one like this on the test, and you know I'm gonna give you something like this, it's not gonna have quite as many parts, yes? This one's kind of overloaded. We figured out what D was, yeah? So therefore I can figure out what C is. C is 180 minus 79. So C is 101.
Also, can you just figure out what C is, because it's supposed to be equal to like half equal to 101.
Do it again. Oh yeah, here. Here also, from the beginning I could have seen that these were alternate interior. I like it. Good, thank you. Of course, being a math guy, I'm always looking for the system of equations, but yeah. This was a very straight, I could have said this from the very beginning. Let's see, what else we have left? We need to know what A is. We know what B is. Yes? And we know B plus A must be D. Yes? I love you guys so much. I don't know if you guys are following at all. These are some of the stuff that we figured out earlier. And as I learn new things, I could just go back and put them in. So D is 79. That's gotta equal B plus A, so A must be 13 degrees. Yeah, a little tiny A dude there. Do we have everybody? A, B, C, D, E, F. Okay, thank God. Okay. So I'm sorry I forgot to finish that one. You just wait. If you are lucky enough to get a teaching job and you get into it, you won't have weeks like I am having. This week is just a perfect storm of everything. Yes.
This is only on 12.1 or 12.5, right?
12.1 through 12.5. Yes.
And then, do we have to know the levels too, like the level 0, level 1? How much of that do we have to know?
You should. That's based on what I asked you. Did I ask you some? Remember, I don't think I got that specific on here. But real quick, you need to know, so level 0, how do you, all right, this is a very evil way to put this. How would you fool a level 0 student from identifying a square? Sure, okay. Level 1, are they gonna have that issue? Level 1 will have an issue with realizing a parallelogram, a rhombus is a parallelogram. They will have an issue with identifying a square is a rhombus. You guys see what I mean? So they're cool with orientation not messing them up, but they don't have the pure definitions. They don't identify a shape still by the definitions. Level 2 is relationships like every rhombus is a parallelogram, yes? Every square is a parallelogram. Every square is a rectangle, yes? You guys see what I'm saying? Do you guys anybody? So do you have to memorize each level by themselves? No. Do you have to understand what it takes to get into the next level? That's what I would focus on if I were you. So how to get into level 1? You're cool with rotations. How to get into level 2? You're cool with relationships. So for example, can a kite be a square? Hell yeah. Every square matches the definition of kite. What's the definition of a kite? Four-sided figure where the two adjacent sides are congruent. In a square, what's true about all the sides? They're all congruent, so are two adjacent sides congruent? Yes, that's a level 2 thought process. By the definition, what is everything that could be a kite? Well, a square could be a kite, a rhombus could be a kite. A kite can be a kite, yes? Do you guys see what I'm saying? That's level 2 thinking. 3 and 4 are like getting into college level thought process, right? That's when you start to do like proofs, angle, side angle proofs, and yeah. So if I were you, I might focus on every shape we talked about and the defining qualities of that shape. And then take a step back and start to realize what other shapes meet those definitions. So what did I just say? The defining quality of a parallelogram. There's only one. Well, it's 2, it's gotta be 4-sided. What's the second requirement to be a parallelogram? Opposite sides have to be parallel. Aren't there a ton of shapes that match that? Do you see what I mean? That's level 2. That's realizing that what we say, when I say parallelogram, that doesn't mean I'm leaving out squares, because squares are parallelograms. They've just been straightened and smooshed until they're the same. You see what I mean? It's still a parallelogram, yes? Now understandably, if I say draw a parallelogram, we're all gonna draw basically this, yes? Tilted, because that's Again, that's our level 0, which we all kind of go back to, all of us. That's our level 0. But then level 2, we have to go, no, actually, yeah, it matches the definition. Level 2 requires us to go back to definitions. So it's not an automatic. So level 0 is automatic. Well, square, oh shit, okay, square does match the definitions. Oh, it's also a parallelogram, yes? And that would help me do problems like the Venn diagram problems. You know, like only you can make kites so huge. I know. It's a superpower. Yes?
I just remember number 9. Can you explain how you got to how you got them?
Which one, sorry?
Number 9.
Where I got which part?
All of it.
Oh, okay, so these are the formulas I will give you. So hopefully you got these in your notes, you can look in the book. So the vertex angles would be, in fact, do you guys remember what n minus 2 times 180? I know, you don't have to know this, but does anyone remember what that gave me? Like how many sides in a square? 4. What's 4 minus 2 times 180? 60. And isn't that the total degrees in a square? So if I do that for any, so 5-sided figure, if I do 5 minus 2 times 180, I'll get the total degrees inside. If I divide that by how many sides it's got, I'll see how much each interior angle gets, each vertex angle. So the definition of a vertex angle is the total number of degrees I'm messing with divided by how many sides I've got. Now, do you have to memorize this? No, I'm going to give it to you, right? I'm going to give you those formulas. You just have to know what to put where. And a central angle, and I actually showed this to you, the central angle is equal to the exterior angle. So that's kind of nice. They each have the same formula. Yeah? So I'll give you those, and you'll see they're the same. That's cool. The central angle, I'm hoping, is a little easier to understand because I have 360 total. So of course, if I just divide by how many sides, I see how much each slice gets. Yes? Is that okay, Peyton? So that's going to be just formulas I give you.
Yeah.
Yes?
Can you go over, it's gonna be the section 1224, number 10.
Oh. Shoot. Oh. So use a ruler to draw the diagonals of the following shapes. So if you want to, you can just trace these on a piece of paper. If you don't have a ruler, you just use your protractor that you have. If you don't have a protractor, I'm sorry, I'll get you one eventually, but you should have a straight edge, yes? Oh, then they want you to measure, so you need a ruler. Determine if the point where the diagonals meet is a midpoint. So real quick, if and this is my book, so I could do this even with pen. If I draw in the diagonal here and the diagonal here, and I'm doing it without a ruler, damn it, see, that's horrible. How do I determine if this is the midpoint of this diagonal? With a ruler. How would I determine this is the midpoint? What would I measure? If this is the midpoint, what must be true about, let me call that one M for possible midpoint, yes? What must be true about EM and MG? They have to be equal if it's the midpoint. So with the ruler, you can just see if they're equal. And again, on your protractors, does it have ruler tick marks?
It has marks, yeah.
Good, okay, good. I couldn't remember if we got the cheap ones or the slightly less cheap ones. Okay. Is that okay?
Yeah.
So trace that. In your homework, you should be doing a decent amount of tracing on your paper and then doing stuff. So I love the stuff I've graded. I can see where you guys have folded the paper. That's kind of nifty. Okay. That's okay, right?
Yeah.
Whoever asked that? Okay. Sometimes I feel like people don't really understand today, but it's really interesting. I always have people that are like, I just want to be here in case anybody asks a question, and then nobody asks a question. You can literally ask anything. Yes.
Can we go over number 6?
Yes. Oh, let me get the blank. Here we go. Yeah, number 6. Oh, number 6. Oh, number 6. This one gets a little tricky with trying to keep track of what's what for yourself. So if you look on my, did I finish that one? I think I did, yes. Let me see if I can see what I'm doing. So like angle BFC is 55 degrees, yes? BFC. AFD, see how it's getting a little tricky to really make sure you see what's going on? AFD is 150 degrees. And BFE, I don't think I did it this way on my paper, but you can do it like that, is 120 degrees. So the first level of this problem that's really tricky is really identifying for yourself what's what. Yes? Do you see how those angles overlap with each other to a certain degree? And it's that overlap that will help you start to get to what I need you to get. So, for example, if I, let me see, how do I say this? Let me see. What is, can I immediately get what this is?
No.
Why not?
Oh, but yeah.
Of course you can. Now, and you do have to make an assumption, and in the test I'll try to be a little more specific about this, but do you see how I'm kind of implying this is a straight line, yes? Okay, I should have said it, and that's my fault, I'm sorry. That is a straight line. So can you get DFE? What should the angle AFE be? 180. Don't you know AFD? Don't you know AFD? Isn't that one of the things I gave us? So I know this far is 150, so what must this far be? 30. Okay. Do you guys see what I'm saying? Now, is that one I asked for? No. But it is useful information to keep going. So now I know this is 30 degrees. Now, what am I asking for? It's like CFD, AFB. So I want to know AFB. I want to know this little piece here. Yes? Does anyone else see something else I could get immediately? If this whole thing is 120, and this is 30, and this is 55, could you figure out what this is? Which is, I think, one of the ones I want, yes? I can't remember if that's the way I did it. Who knows, Jeff? I think I did. Oh, I did it a different way. Neat. So let's see if we get to see next week. I really want you guys with me. So angle DFE is 30 degrees. This whole thing is 120. So if I do 120 minus 55 and 30, right? If I do 120 minus this and minus this, I should be left with this. Does that make sense? Do you see that?
Yes.
Because all three of those angles make the whole thing. So if I take the whole thing minus two of them, I should get the third one. And do I get the same answer? Yes, thank the gods. I get 35 degrees. And I did it a different way on the key. So obviously, is there more than one way to do this? Of course, because somebody's going to see something else that they can get first, which is going to lead them down a different path. I think the hardest part of this problem is just identifying for yourself which angle is which. I think I did a better job here than I did on my key, but that's okay. But do you guys understand the underlying approach? It's kind of like if I give you enough angle measures, this angle is made up of these two, and if I know two of them, I can figure out the third one. I mean, that's the whole idea of this kind of problem. Right? AFB, oh, AFB you could figure out immediately, right? 60, yeah. Is that how fast Jeff got? Now I can't remember which way I did it. Did I even get AFB? Poor little Jeff. So AFB, oh yeah, I did. I just didn't say what it was. AFB is 60. I think I did it a different way. Okay. Let's see. Say again?
So I
Oh.
got,
Did you get more than I did?
yeah,
What you, let's see, so I got, these four, what else did you get?
so I got the AXE and the BXE, and then I wrote it the opposite way. You wrote AXE, I wrote.
DXA, you're good.
I,
As long as the X is in the middle.
The other two that I got.
Yes, yes.
Were CXA and EXA.
CXA is definitely less than 90. And what was the other one?
Oh.
And DXA I have. I just have it this way.
And then EXA?
EXA I have. I just like the word X, so I put it that way.
Oh, you just wrote it once.
Do you guys see how an angle could have three names? So I could call it ABC, I could call it CBA, and if I had just one angle, I could call it B. Now this one I can't do that because I have multiple angles all coming from the same point, so I can't give any of them a single letter name. Does everybody see that part? So AXE is the same angle as EXA. Neither ray is more important than the other one, so you can name it this way or that way.
And then how did you figure out that BXA or BXD was?
BXD?
Yeah.
Oh, okay.
Because it looks really similar to like the angle.
Real quick. Alright, this problem is a little tiny bit evil. Because I'm not letting you use a protractor. But can you guys see how this ray is kind of like further back than it should be if I wanted to make a right angle here? So see how I rotate my paper, put the D like it was the x-axis, and then I can see very quickly that that's leaning back, making it bigger than 90? Yes? Okay. Yes?
Quadrilaterals, can we go over like basic definitions for each of the shapes, so I can give a list?
Oh, okay, let's see. So quadrilaterals, four sides. That's the topmost idea. We drew a picture together. There's like the parallelograms. You guys remember what was over here by itself? Trapezoids. And then what came off the parallelograms? Rhombuses and rectangles, yeah. Now, real quick, this is not what you're really asking for, but, so quadrilaterals are four-sided. What's trapezoids? What's the definition of a trapezoid? Pull up, it's a trapezoid.
One pair of parallel sides?
Huh?
One pair.
Yes, exactly one pair of parallel sides. And that's why it's off by itself, yes? It cannot fall under parallelograms because parallelograms need two pairs of parallel sides. There was even something on the side. Okay, so trapezoids, exactly one pair of parallel sides. So a parallelogram could never be a trapezoid or vice versa. Parallelograms, two pairs of parallel sides. What about rhombuses? A rhombus is a parallelogram where all sides are congruent. Yep. So, if you think of a rectangle as a perfect shape, let's just say yes. Why is a parallelogram not perfect? 2 reasons. A general parallelogram, I'm sorry, back up a second. But think of a square as a perfect quadrilateral, yes? And in fact, it is a regular foregon, so it's kind of like, it is a square. Why is a parallelogram not perfect if a square is what I'm considering perfect?
The sides aren't equal.
Second,
The sides
sides aren't
aren't equal.
equal, and the angles aren't equal, yes? So, if I rectify one of those, if I make all the angles equal, but I don't change the sides, I get a rectangle, yes? If I instead make all the sides equal, but I don't make the angles equal, I get a rhombus. If I then correct the last thing wrong with both of these, if I make this one have equal side lengths and I make this one have equal angles, I finally get to my square. I don't know if this is helping me out, Natalie, I'm sorry. So you want like so a rectangle is a parallelogram with 90-degree angles. A rhombus is a parallelogram with equal side lengths. So to me, the way I would define shapes is based on some more general shape, right? Okay. And a square is a parallelogram where all the sides are equal in length and all the angles are equal. You guys, and I don't know if anybody really, I kind of appreciate that. I love that idea. Correct it one way, correct it another, correct both ways, beautiful. Now, does anyone remember what's like off to the side of parallelogram? Kites, yeah, kites are strange. They don't have to have any parallel sides, right? So kite, your basic kite has a big chin, yes? Is that okay? Show me what you got. Yeah. And then if I take the kite, I don't know if you guys are really with, can you guys see a kite between my hands? Do you guys see a kite between my hands in your mind's eye? And I just do this. If I do this enough, stop at the right place, I have a rhombus. Maybe. If I push the chin up enough so all the lengths are the same, I have a rhombus at least. It might be a square if I made this angle 90 degrees to begin with. Guys, this is like a little level up from what you're asking, Natalie. It's a little level up from what you guys have to know, but it kind of is a neat way to consider how to make one shape become another shape. So a kite can become a rhombus, and then a rhombus can become a square, and that's why there's that thing. But a kite cannot be a parallelogram, a general parallelogram. Okay?
So it would be safe to say that a rhombus either has 4 equal angles or 2 acute and 2 obtuse opposite.
A rhombus cannot, oh I see, okay. A rhombus could be a square. So yes, you could say a rhombus could have equal angles, but what must it have? That's the difference. What must a rhombus have? Equal side lengths. And of course, opposite sides parallel because it's coming from a parallelogram, right? You guys see what I'm saying? So could a rectangle have equal side lengths? Of course it could. Then we would call it a square, but it's still a rectangle, it's just a specific rectangle. Must a rectangle have equal side lengths? No. So if I was like, what's one difference between a rectangle and a rhombus? A rhombus must have equal side lengths and a rectangle does not have to. Right? That's like the quiz question, yeah? That is one thing you could have said that would have been a difference. Are you guys? Okay. So you guys are scrolling. I'm gonna make a catch me scrolling. I'm bored. What's it? Is that song reference too old now?
I don't think so.
Riding dirty, yeah. Of course, I'm white and nerdy. Catch me white and nerdy. Okay. Any more about this? I don't think I quite gave you exactly what you wanted, Natalie, but
I got it. I
Okay.
put it together really
To me, it's just better than just memorizing definitions separately,
Yeah.
is to build them off of where they came from, yeah. I mean, this is such a cool, you can imagine, constructing something where it's a rectangle, and then if you just actually literally, it's almost like those sliding things you can do in pop-up books. You just smoosh it together, and then you're like, now this is a rectangle that we also call a square, because I made all the side lengths the same. You can see what I'm saying? That's the kind of thing you can do with little ones as they learn about all this weird stuff that has happened in history before they were born. Basically what math is catching up with all the weird shit that math people did over the centuries. Alright, number 11, was number 11 okay? It gets a little busy over here, so I'm not gonna give you like more sides than this, cause I know, let's see, anything else we didn't talk about? I think we talked about just about everything except, well, these guys, but hopefully those weren't too bad. Could an isosceles triangle be equilateral? Yes. Isosceles has to have at least two sides that are equal, and if I just made the third side equal also, it would be equilateral. But does every isosceles triangle have to be on the far side? And real quick, do you see the way I wrote part B? If you draw a circle, don't have an interior, pretend like this is a circle. Don't have an interior part and exterior part. If I'm focusing on the outside of the circle, can I draw 2 points that when I connect them with a line segment, I don't stay in that region? Yes, I just did. So the outside of the circle would be concave. The inside of the circle would be convex. Does that make sense? That's why I had to be very specific. The region inside the circle is concave. By the way, do not take this as if I'm saying get out of here. But if you're ready for the test, you can leave whenever you want. So today is all about review. If you have no more questions, you can head out. If you have more questions, I'm here. Yes? Yeah. Oh, well, sure. Which one is it? Okay. Oh, you're fine. I forgot what the question was, so you just put more than you need. So that's also trying to not confuse anything. You said, for example, there's ICG. Okay, I see. Okay. Alright. Now I'm just forgetting what the question was asked. So part C says a kite that is not a long Where's it on your there? And that's part C. That's why I was confused. Height that is not a wrong. Very asking. You said it was I. Oh. Sure. No. Okay. That's fine. That's perfect.
Okay.
Yeah, I think you put a little triangle symbol. Yeah,
Yeah.
definitely don't put that.
Yeah.
Any four-sided symbol in front of it would work.
Oh, okay, yeah, I did that with these ones.
Real quick, just a little one second. If, I'm gonna run this backwards. If I had a scalene triangle that was ABC, do you see how I would still use the same little symbol? I wouldn't try to make the scalene.
Yeah.
So the symbol we use in front If I have a four-sided figure, I'm gonna use that symbol, yeah.
Okay.
Even though it could be, a trapezoid or whatever, does that make sense?
Yeah.
Okay. But if you try to make a symbol that's more specific, you're not wrong, I'm just on that, yeah.
And then the number D, I don't know how that.
T was T said, right, scaling triangle, you said R, where there's R and G. Where's G? Thank you. R and G is, yeah, it's definitely a right scaling. Yeah. You're fine. My,
It kind of looks like I put. Well, that's probably wrong.
could be. Could be. It also could be, one thing I noticed, let's see. If you're surprised to hear what I'm about to say, then you don't understand what teaching is. I didn't necessarily go back and double check the question versus the answer key. You know what I mean? And then I noticed in one, I think it was section 12.3, the answer key had nothing to do with the actual question, and I was like, oh shit, so I had to go back and, cause I noticed a few people doing the exact same thing, I'm like, what the shit is this? You see what I'm saying? I don't always have all the time to do that. So on a couple of those, they could have put an answer when there were actually a lot more possible answers. You know what I mean? So I think that might be what happened on a couple of those, yeah. Yeah. Yes,
Okay, so the homework is due on Monday,
yes,
and then when are our quiz corrections?
Monday,
They are due Monday?
yes. Now, you could turn in quiz 1 corrections on the day of the final and still get some points. You get enough of one. It's just very late, so you won't get anywhere near as many points as you would have. You see, so everything has a due date, but you could turn in things late. And I'm okay with that because the final's cumulative, so anything you do at any point is helping you. But if you give it to me by Monday, you'll get as many points back as you possibly could.
Since I have a makeup quiz, how would that change for me for the quiz?
You can make corrections, I'm gonna give it back to you on Monday, so then you will have a little bit of time to make corrections, because obviously you couldn't give it back to you the day that you did it back. That would be me, yes. The practice test? Yeah. They're written on all of them, no. Okay. Yeah.
Saying that, Judge, this is correct, or that
Oh, when I say correct, it means correct mistakes.
is? Okay,
Yeah.
that's fine.
Believe it or not, leaving out the word mistakes saves so much time. It's kind of, I guess. Where did I put them? Where did I put them? Oh, they're here, yes.
This is just homework.
Oh, cool, right there. Yep. 9. Oh yeah, so again, I'm gonna give you these formulas, n minus, get out of 12, n minus 2 times 180 is the total angles inside. And if I divide that by the sides, I get a measure of the vertex angle. For example, right? So each one of those questions in math number 9, I'm gonna give you. So I would give you vertex V equals that.
Okay, and then C equals this, and then E.
Yeah, exactly.
Okay.
I told you guys I'm gonna
And then
not make you
N would
memorize.
be 12 or
Exactly, for those questions, and it's 12 and 10.
10. Okay, cool.
Oh yeah, sure. Oh, yeah.
I was wondering, what is more out of this?
It must have 2 decimals 2. Oh, so what kind of shape is that? What do you call that shape? So if it must have 2 sets of parallel sides and
So you just want the name of what it is?
yeah, Does it make sense?
Yep.
Okay.
So the moment a rectangle is not, it's not 90 degrees, it's just parallelogram.
This is the parallelogram. Yes. This is the rhombus.
Right.
Yes.
Okay. That's something.
Oh, I always forget I have these. This is what I talk about. So if I take kite and I push it, I could make it even. Yeah.
Okay, because I don't know why I thought it was either, you could either have a square, a rectangle, or a rhombus. I thought it was just those two categories, but now that's a subcategory to the category of parallelogram.
Yeah, parallelogram
So those
is
are
kind of like the Danny.
So those are the two ways you can go, but you can also just stay as a parallelogram.
Yes.
Necessarily.
Yes.
Okay.
So
That,
this is a parallelogram
Mhm.
that we also call a rhombus. This is a parallelogram that we also call square.
Mhm.
Yeah.
Okay, I got it.
Talk for me, what exactly was this meeting about, cause I met with a different counselor?
I know. Sure. I had issues with the way Scott handled the situation, so if it's not an official termination,
That is what he is saying, kind of, it's like a
but
compromise.
the fact that
is
he,
what he said. Yeah, my mom on the phone was like, a little fishy about the way he handled it as well.
Yes.
It was like, it is.
it's a
what it is.
really an undue, so I wrote back to him and said, it's undue pressure on me, because I am not a specialist in identifying, needs in accommodations. That's not my purpose. My purpose is to maintain the integrity of the course and make sure every student has the same, access to whatever, right? So anyway, I'm meeting with Carl Thursday. Cause that's the soonest, today's insane, like crazy busy.
Oh, yes. I
And the
agree with
minute
you
that
said.
he and I
It's been
figure
so-
something out, then we're gonna let you know.
Okay.
So-
Basic question, am I going to be able to use the?
I do not know that.
Oh,
I'm really sorry that it's come down like this. I thought
Yeah, it's
that
fine.
that was part of the whole thing.
Yeah,
And then it isn't. So I'm in a weird place right now.
Oh, we're both in a weird
I know,
place right
I know,
now. I
I
had
know.
to schedule an
It's
appointment
not right. The way that they handle this is not right.
And I need to make up the quiz, and it takes
The quiz?
7 days to actually make an appointment there.
Look, you can make a quiz if you want to, or we just count success for replacing the quiz.
Yeah, I think I'm gonna do the test.
And if it turns out that you won't be able to use those, then I'll give you some more time if you need it to really get ready for the test, because
Yeah.
that changes the way you're trying to do it. So, okay, so I'll let you know the minute that we know anything.
Yep.
I just need Carl's, I need someone else's take on this, because the way Scott handled it was not right. So, and I'm really sorry about where this puts you.
Yes.
Right, but I want you to, you hear me, then I'm gonna work, give you some flexibility, because
Yes.
I understand you're in a weird place with this, so I'm not gonna suddenly.
Yes, cause I was like, oh, it's not a combination, it's like we and the teacher meet up personally, and it's like a,
But then see, I'm a teacher, I'm not a, I don't analyze accommodations based on situations students are, I have
I
zero.
forgot the way you worded it, it was like some sort of fancy term, like something.
Yeah,
Teacher.
yeah. But see, I don't do that, so that's outside of my abilities, so does that make sense?
Yes,
So I
it
just
does.
I want somebody else, and Carl, I worked with him before, we've worked a lot together, I like Carl. So if I can get him to kind of go over this with me, he thinks Scott didn't really handle it well either. But after that meeting, I'll see his opinion, and then I'll let you
Yes,
know.
I was just.
I just don't feel qualified to make that call myself, does that make sense? So, there's all kinds of outcomes that could happen, but I'll let